Hi everyone, Bemnat here and welcome back to our series on statistical hypothesis testing. In our last video, Selena walked you through the process of performing hypothesis testing by hand. In this video, I'm here to complement that by showing you how to perform the same process using Python. Along the way, we'll revisit why hypothesis testing is such a powerful tool and how Python makes it not just faster but also less prone to human error. Let's briefly recap what hypothesis testing is all about. Hypothesis testing allows us to make informed decisions about data by evaluating whether observed differences are due to chances or some underlying cause. It starts with two hypotheses. The null hypothesis assumes that there's no difference or effect, and the alternative hypothesis suggests that there's a difference or effect. In our example, we're testing if Kenyan women 100K runners are faster than Ethiopian women runners. The null hypothesis says that there's no difference, while the alternative hypothesis, Selena's hypothesis, says Kenyan runners are faster. By hand, hypothesis testing involves calculating means, variances, T-statistics, and comparing them to critical values. Let's start setting up our data. We have two samples, times for Kenyan runners and times for Ethiopian runners. The records Selena extracted her samples from are these two files right here. We went ahead and extracted two random samples from each data frame. This should be the same sample that Selena worked on. So I'm going to run this cell right here, and these numbers should be similar to what Selena was working on. Now, let's actually go ahead and calculate the mean of these two groups so we can start making our arguments. I'm going to print the average for I'll just say average Kenyan time. And then this will be the mean of this list right here. And will be the mean of these lists right here. And for these to work, I'm going to come here and from the statistics library, I'm going to import mean for the function to work, and let's run this. Let me correct this right here. This should be mean and not Mina. And I'll run this. And so these are the averages. So this makes sense because Selena found that the Kenyan time is faster than the Ethiopian time, which is reflected here by the smaller average. And now we want to see if this finding is statistically relevant. So what we're going to do is just perform the t-test. And in Python, we don't have to calculate any of the mean, the variance, or the t-statistics by hand. We have a function that we can just import and pass our data to. Now let's go ahead and see if this finding is statistically significant. Let's set up our hypothesis. Our null hypothesis assumes that the Kenyan runners are not faster, while the alternative hypothesis, Selena's argument, states that they are. This calls for a one-sided or one-tailed t-test. Before diving into the calculations, let's talk about the significance level. The significance level, denoted by alpha, is the threshold that determines how much evidence we need to reject the null hypothesis. A common choice is to set alpha to 0.05. That means we're willing to risk a 5% chance of concluding that Kenyan runners are faster when they're actually not. That means when there's actually no difference in the runtimes. So let's see how we can actually perform the t-test using the Python notebook. The scipy.stats library includes a test method that you can just call, pass in your data, and you get your results back. So let's do that in this cell right here. So from scipy.stats, I'm going to import the t-test independent function, and this should be stats. And to this function, we're going to pass in our Kenyan sample, our Ethiopian sample, and then set in a few optional data parameters. The first one being the alternative parameter, which by default is set to both-sided, but because we're doing a t-test, we're going to have to set it to either less or greater. And since we want to argue that this first Kenyan sample is less than the Ethiopian data average, we want to set this to less. And the other one other parameter we want to set is the equal variance parameter. Since we don't actually know the population variance of these two samples, we don't want to make an assumption that they're equal, so we'll do a Welch t-test and set these two false. Now, this function returns a couple of things. One of those values is going to be the t-statistics. I'll just call that t-stat. And then the other one is going to be the p-value. And we'll unpack these like this. Now, let's print whatever we're going to be getting from these. One of it is going to be the t-statistic. And the other one, we're just going to print this. And the other one is going to be the p-value. So let's go ahead and run this cell. And this is what our output is, going to be. So let's talk about how we can interpret this output. The t-statistic, this value the first value right here, is going to be the difference. It tells us about the difference between the groups in standard error. It measures how far the observed difference is from the null hypothesis in terms of standard error. We'll come back to how we can use to prove our hypothesis, but let's move on to the p-value. The p-value shows the probability of observing such a result if the null hypothesis had been true. If the p-value is smaller than our predefined significance level, which we already set to 0.05, we reject the null hypothesis. Since p-value here, which is 0.01, is less than 0.05, we can go ahead and reject our null hypothesis. That means it is not true, or it's not probably true, that we can get this result if there had been no difference between the Kenyan runners and the Ethiopian runners. The p-value tells us the probability of observing such a result as extreme or more extreme than what we've observed, assuming the null hypothesis to be true. The smaller the p-value, the stronger evidence we have against the null hypothesis. To confirm if whether or not our finding is true, we can go ahead and use the t-statistics and the critical value to further strengthen our argument against the null hypothesis. And in Python, you can use another library that you can just import and pass in your t-statistic value, your degree of freedom, and your significance value to get the critical value. And we can go do that right here. We're going to start by importing the T library from the scipy.stats. We're going to import T. And then we're going to use the probability point function, PPF, to calculate the critical value. For this, we need two things. We need the significance value, which was alpha, and we've already agreed to set alpha to 0.05. And we also need to pass in, I'll come back, and this needs to be 0.05. And we also need to pass in the degree of freedom. There are other ways that you can accurately calculate the degree of freedom, but for the most part, when you're doing a two-sample test, you can approximate your degree of freedom to be your sample size minus 2. So that is going to be, we have 10 samples in each, which is going to be 20 minus 2, which is going to be 18. If you want a more accurate value for your degree of freedom, one of the values that are going to be returned from the independent t-test function right here is also your degree of freedom, and you can go ahead and extract that value. We'll just stick with the approximation 18 because it doesn't seem to make that much of a difference. Now let's calculate our critical value. Critical value is going to be called the PPF function and pass in 1 minus alpha and our degree of freedom, and that was going to be our critical value. So we're going to print critical value to whatever is going to be calculated here. Let's go ahead and run this. And this is going to be 1.73 is the critical value that Selena also looked up in her video. So now that we have the critical value, we're going to compare the critical value to the T-statistics value right here. If the T-statistic value is less than the critical value that we found right here, we can go ahead and reject the null hypothesis. So both ways lead to the same conclusion. And that's how you use Python for hypothesis testing. By automating the calculations, Python helps you focus on interpreting the results and making data-driven decisions. That's all for this video, and see you in the next one.